All right, so linear inequalities. When you have a line, you'll be able to know how to graph the line. Whenever you graph the line, you've divided the plane into two parts. I'm going to say region 1 is above the line, region 2 is below the line. But when we're doing inequalities, we don't have an equal sign. So when you have an equal sign, we're just talking about the line. But when you have an inequality, so a less than or a greater than or a less than or equal to or greater than or equal to, you're going to end up with one of the two regions getting shaded in, either going to shade above the line or below the line. Now, when it's in slope-intercept like form like this, so the y is by itself and mx plus b, you are going to, this is telling you where to shade. It says y is less than the line, so you're going to shade below the line. But that little trick only works when it's in slope-intercept form. On the next slide, I'll talk about standard form. The other thing you have to remember about with linear inequalities is what is the line? You have two choices. It can either be solid or dashed. So if it's got the equal to, so less than or equal to or greater than or equal to, you get the line itself. It's going to be a solid line. That means, so the shaded region is called the solution set. So those are all the things that make it true. So I'm going to pick some point over here. So let's see, I'm going to go over here to 7, -2. So if I plug, no, let's go 8, -2, because I just don't want to deal with the fraction. So if I pick 8, -2 and plug it into my equation, please see I get 8. Half of 8 is 4. And then 4 minus 2 is 2. So I get 2 on the right-hand side. And then my y value is what I said, so -2. Is -2 less than or equal to 2? Yes, it is. So that means it's in the solution set. So all the shaded region is part of the solution set. When you have the equal to sign, that means we include the line in the solution set. So let's pick a point on the line. 4 is 0. When I plug 4 in for x, I get half of 4 is 2. 2 minus 2 is 0. And then I would have 0 is less than or equal to 0, which is a true statement. So that's why we have it be solid. Okay, next slide. Okay, so now here, the top one is what it would look like if it was given to you in standard form. So my advice is to take it from standard form and convert it into slope-intercept form. I'm showing you how to do that. The one thing is you got to remember with inequalities, if you multiply or divide by a negative number, you're going to flip the inequality. Okay, so file that away. Somebody else was supposed to tell you that before me. Please see that this one is a less than sign right here, so we know it's going to be a dashed line. Okay, and when I converted it, look, it's the same line that we just had before. But now because it's dashed, it doesn't make it true. So I'm going to come down here to 0, -2. I'm going to plug in 0, -2. In this equation, I get half of 0 is 0. 0 minus 2 is -2. And then I have the -2 over here. Is -2 greater than -2? And the answer to that is no. -2 is not greater than -2. It's equal to. So, and then please see when I plug it into this one up here, I get 0. And I get -2 over here, so -2 times -2 is 4. So 0 plus 4 is 4, and 4 is not less than 4. So that when it's a dash line, you don't include that. And once again, please see the little trick. Here's my line, but I got a number over here, so that doesn't tell me to shade below the line. You got to convert it into slope-intercept form to be able to use that. The other way to do it is you only have two sides. You pick one side, see if it works. If it works, shade that side. If it doesn't work, shade the other side. Okay, now all that was supposed to be a review. This part is new to us. So now you are shading two lines. And the solution set ends up being where those two, so when I do let's see, this one over here. Well, actually, let's do this one because it's in slope-intercept form already. So let's see, slope-intercept form, it's got a y-intercept of -2 and a run of slope of 2. So that's this one, right? It starts at -2 up 2 over 1. And it's got a solid line because of that little equal sign right there. So we're looking at this side over here is the solution set for this linear inequality. And then this one, okay, if we, let's see, get y by itself, so I'm going to subtract x, so I would get negative x plus 3 on the right, I have 2y on the left, and then I divide by 2. Okay, I didn't divide by a negative, so I just keep the inequality the same. I get y is less than negative 1/2 x minus 3/2. Sorry, plus 3/2. So please see 3/2 is 1.5, and it's got a slope of negative half. So down a half over 1, down 1 over 2, whatever the case may be, it's that line. And so that would end up shading this side. So the solution set for this linear system of inequalities is where those two lines, shaded regions, overlap. So this dark shaded region is the solution set. And what that means is anything in here will work in both equations. So I'm going to pick this one, negative 2, 0. I plug in negative 2 in here, I get negative 2 plus 2 times 0 is 0. Negative 2 plus 0 is negative 2, so I get negative 2 is less than 3. That's a true statement, so it works for the top one. And then try it again. If I plug in a negative 2 for the x, I get 2 times negative 2, negative 4, minus 2, negative 6. And then I would have the 0 over here. Is 0 greater than or equal to negative 6? Yes, I would rather owe somebody nothing as opposed to owing them $6. So that's true. So the dark shaded region is the solution set to this linear inequality. Okay, I think